Unacademy. Let's crack it.
Hello, my dear friends. So this is the thermodynamics full syllabus topic, first law of thermodynamics. So जो बोला चलो मुझे पहली बार देख रहे हैं, my name is Mohammed Shirtan. I am having 9+0 teaching experience, mentor more than 1 lakh students across India, and work as senior faculty in many reputed across India. So अगर हम अनअकैडमी सब्सक्रिप्शन की बात करें तो आपके पास दो टाइप के सब्सक्रिप्शन ऑप्शन अवेलेबल है, प्लस और आइकॉनिक। प्लस में आपको मिलता है लाइव क्लासेस, वीकली टेस्ट, स्ट्रक्चर कोर्स, अनलिमिटेड एक्सेस ऑफ ऑल द लाइव एंड रिकॉर्डेड क्लासेस, रैंक अपने बैचेस और क्रैश कोर्स। आइकॉनिक सब्सक्रिप्शन में आपको मिलेगा ऑल द बेनिफिट ऑफ प्लस सब्सक्रिप्शन अलॉन्ग विद पर्सनल कोर्स, स्टडी प्लानर, स्टडी बूस्टर सेशन, पर्सनलाइज्ड टेस्ट एनालिसिस, स्टडी मटेरियल एंड डेडिकेटेड डाउट क्लियरिंग सेशंस। बात करते हैं अनअकैडमी सब्सक्रिप्शन की, तो आपके पास दो टाइप के सब्सक्रिप्शन ऑप्शन अवेलेबल है, प्लस और आइकॉनिक। प्लस मिलता है आपको 12 मंथ का 2704 पर मंथ, एंड टोटल फीस आपको पड़ता है यहाँ पर 32,450। एंड आइकॉनिक सब्सक्रिप्शन आपको मिलेगा 12 मंथ का 4,704 पर मंथ, एंड टोटल फीस आपको पड़ेगा 56,450। यू कैन अप्लाई माई कोड पठान टू गेट ए 10% एक्स्ट्रा डिस्काउंट ऑन अनअकैडमी प्लस सब्सक्रिप्शन। बात करते हैं अनअकैडमी के लाइव मेंटरिंग प्रोडक्ट की, तो अनअकैडमी एक लाइव मेंटरिंग प्रोडक्ट है। इसके थ्रू आप अपने एजुकेटर से डायरेक्टली डाउट पूछ सकते हैं, अपनी जो भी क्वेरी है वो सॉल्व कर सकते हैं, ठीक है। बात करते हैं स्पेशल क्लासेस की फीचर की। So special classes are very interactive like classes. Here you will get the report for the learners option. You can raise the hand. You will never miss the classes because you will get the notification for the lessons and upcoming courses and recommendation for current and just for you. And you can download the lecture notes after the class, and you can see the class at any time, anywhere. Now let's talk about an academy doubt session key. If you have any doubt on academy or related to the subject, you can ask that doubt on academy platform. And for that you should upload that an academy doubt, okay, screenshot of your doubt or PDF of your doubt, and select your preferred language. So then you will get a high quality video solution of your particular doubt. Already an academy started batches for GATE or ESE 2023 and 24. So you can join these batches right now. Let's talk about Unacademy Lite subscription. In the Unacademy Lite subscription, we have a mix of topics and subject-wise mock test series, access to structured test, and detailed solution and performance analysis. Let's talk about the GATE or ESE. So in the GATE ESE category, if you get a 12 months subscription, you get 3 months extra, and if you get 24 months subscription, you get 4 months extra. And price hike is coming soon. If you plan for GATE 2023, so there is a price hike is going to come. So now you have a special price week up to March 31st 2022, okay, and this is the lowest price ever offered by Unacademy on any subscription. So if you want to take an Unacademy subscription, take it right now and apply my code Pathan. So to get this special price, you need to apply this code Pathan. Suppose the iconic fees is 62,600, current fee is 56,000. Special price offered by Unacademy this time is 50,804 to you, and that means you are saving 16,371. That means 26% you are saving on subscription. 16,000 you are basically saving on one subscription. So suppose current fees is 72,000 for 18 month subscription, okay. So after the code you will saving Unacademy offer you 65,250. So this offer valid up to March only. So you use my code and get a subscription on this special price. Last class में मैंने आपको एक क्वेश्चन दिया था. In our last class we were discussing this question from the first law of thermodynamics. Anybody solve this question? Anybody solve this question or not? Anybody solve this question or not? Okay, so I'm going to solve this question for the student. Suppose so, yeah, I'm going to solve it. Suppose the P1 pressure given in the question is 3 bar, that is 300 kilopascal. A specific volume given in the question, so with the help of a specific volume, you can find out the total volume because the mass of the bag is also given in the question. It is 0.1 kilogram, okay. 0.1 kilogram. So 0.1 into specific volume is 0.001002. So now the total volume will be 0.00010002 meter cube. P2 pressure is 10 bar, that is 1000 kilopascal. So V2 volume is going to be 0.1 into 0.001 point the volume is 0.01321 meter cube. Now because in this question it is given the relation between pressure and volume is linear. So that means the process between in pressure volume diagram will be a straight line, not passing through from origin. So area under this line will be the total work done in this process from 1 to 2. So you know the pressure at 1 and pressure at 2, volume at 1 and volume at 2. So the work done is going to be 1 upon 2, 300 plus 1000, difference is 0.01321 minus 0.00010002. Again, so work done in this question will be, sorry, I have to add some pages. So work done in this question is going to be W equal to 8.52 kilojoule. This is the work done. Capital U by M. Small u, that is specific internal energy, is capital U by M. So U can be write as 0.1 into 130 134 given in the question. So 134 point kilojoule. Similarly, U2 you can also write this is specific internal energy. So total internal energy can be write as mass into small u. 0.1 134.7 kilojoule. So now you know work done and you know the change in internal energy. So according to first law of thermodynamics, dq equal to du plus dw. So change in internal energy is equal to u2 minus u1. So 134 minus 7 minus 113.4. And work done is 8.52. So total heat accumulated in this system is 129.82 kilojoule. This is the total heat which will add to this bag. Suppose this is the bag like this. So total heat has to be added in this bag is 129.82 kilojoule. Now what happened? Some amount of heat is coming to the bag, that is 75 watt, and some amount of heat goes to the surrounding, that is 25 watt. So the total heat, net heat coming to the bag is 50 watt. That means 50 joule per second heat is coming. So suppose T time required to come this amount of heat. So when you multiply 50 into T, and this amount of heat will accumulate in the time T. So T equal to 129.82 kilojoule, because it is kilo upon 50. This is the time required to accommodate this much amount of heat inside the this bag. तो इतना हीट आने में हमें इतना टाइम लगेगा, क्योंकि 50 जूल हीट जो है हर सेकंड इस बैग में ऐड हो रही है, क्योंकि 75 आ रहा है, 25 निकल जा रहा है. तो 75 watt is adding to the bag and 25 is leaving to the bag. So 50 joule heat accumulate inside the system. So net heat which is coming inside the system is 50 joule. So when you multiply it by time, what happens? The total amount of heat will coming in particular time will. So to change the properties as given, this much amount of heat must come inside the system. So the T time required to come this amount of heat. So you can calculate this T time, and this T time will be 2596.4 second, or T equal to 43.27 minutes. This is the answer. So amount of heat accumulated inside the system is 129.82 kilojoule, and the time required to come this much amount of heat is 43.27 minute, or 2596.4 second. I hope this question is clear to you now. Let's come to the next question. Question: a vertical cylinder of cross section area of 0.1 meter square fitted with a frictionless piston contains air at pressure of 120 kilonewton per meter square. Air is mixed by a paddle wheel for air for a 10-minute. The shaft of the paddle wheel is running at 250 rpm with a torque of 0.5 Newton per meter and is driven by a motor during the same and is driven by a is running at 250 rpm with a torque of 0.5 Newton per meter and is driven by a motor during the same period. The electrical resistance kept in a cylinder and is connected to an external 24-watt battery draws a current of 0.45 ampere. Then find the distance through which the piston rises, the heat transfer from air to surrounding is 5 kilojoule and the internal energy increases by 2 kilojoule. ठीक है, this is the question. तो यहाँ पर एक पिस्टन सिलेंडर इंजन दे रखा है, क्वेश्चन को पढ़िए आराम से. I have give time to solve this now. Sangam, solve the question. Take your time to solve the question. Need a full solution of the answer. I need a full solution of question. ये नहीं हुआ क्या क्वेश्चन? ओके चलिए इसको सॉल्व करते हैं हम लोग. यस थंडर एसके, वी आर गोइंग टू सॉल्व दिस क्वेश्चन नाउ. तो सपोज यहां पर आपका पिस्टन सिलेंडर अरेंजमेंट है. दिस इज योर पिस्टन सिलेंडर अरेंजमेंट और यहां पर आपका क्या है, मोटर लगा हुआ है. So the motor is running the fan. Here you have a resistance. This is your air. ठीक है. What happened? This motor is running a fan and this resistance also supply the work done. You know that the heat transfer equal to change in internal energy plus work done. Here we will have a three kind of work done. One is called electrical work done, because when electrical wire basically placed inside the system, it supply the electrical work to the system. So first we have a electrical work. Second, we have a pedal wheel work, because this motor basically running this fan, so we have a pedal wheel work here. And third one will be a displacement work of the piston. So this is the piston work. So the net work done will be a summation of the electrical work, pedal work and the piston work. Okay. Now in this question, the heat transfer from air to surrounding, that means the heat loss from the system. Okay, given the question it is -5, so the dq equal to -5 kilojoule. Okay, and again the internal energy increased by, so that means du is positive and it is 2 kilojoule. So when you put 5 kilojoule, it is 2 kilojoule and the net work done again dw electrical, ठीक है, dw pedal, okay, and dw piston work. So this is the work done. So the net work done you must going to be -7 kilojoule. So this should be net work done. Okay. Now we will find out the all individual work done. Okay. So first we have a electrical work done. So the electrical work done, dw electrical will be equal to voltage into current, but this work done in joule per second. So per second work done will be voltage into current. So if this electrical wire plays inside the system for certain period of time, suppose 10 minutes, so in 10 minutes what amount of total work done will be supplied by the current? It will be voltage into current into 10 into 60. When we multiply by the time, it will be total work transfer to the system in that particular time. So it will be a joule then. So voltage given the question, it is 24, current is 0.45 and 10 minute into 60. So the total work done by the electricity will be 6.48 kilojoule. This is the electrical work done. Now come to the pedal wheel work. So again the pedal wheel work is nothing but a T into omega. Torque into omega, that is angular velocity. So again the unit of this T into omega is joule per second, that is watt. If you want to find out the work done in particular time, so you must multiply this T into omega by that amount of time. So omega, you know that it can be write also 2 pi n T by 60 into T. So this is the pedal wheel work. So to calculate the pedal wheel work, in the question the RPM is also given in the question, because the shaft running with 250 RPM and torque supply is 0.5 and it is running for 10 minutes. So we will multiply 10 into 60 to this whole value. So then you will get the pedal wheel work and it will be 7.848 kilojoule. This is the pedal wheel work. Again, now So we know the pedal wheel work, we know the electrical work, and we know the W net work done. Okay. So when you put all the values in W net, this is minus 7 kilojoule. Pedal wheel work is 7.848 plus electrical work 0.648. All are in minus. Why? Because all work supplied to the system. Okay, it's not plus piston work done because this work is done by the system. So now you can find out what will be the piston work done by this equation. So it will be 7.328 kilojoule. And you know that piston work done or the displacement work done can be write as PV2 minus V1. 7.328 kilojoule. Okay. In this question he said that the piston move under the constant pressure. Okay. So when piston move under the constant pressure, it is 120 V2 minus V1 and 7.328 kilojoule. So now you can find out V2 minus V1 value. It is 0.061 kilometer cube. So if you want to find out how much amount the piston displaced from its initial position, okay, you multiply V2 minus V1, that is change in volume, by area. So X equal to V2 minus V1 upon area of the piston. So it is going to be 0.61 meter square, meter, because the area is 0.1 meter square. So this is the answer, 0.61. Okay. So in the next class we will start the flow work. In the next class we will discuss about the free expansion. In the next class we will discuss about steady flow energy equation. Okay. So for today this is enough. Yeah, one homework. Very good. If you required one homework, I have for you. Very, very good. I'm very happy. क्लास में हूँ, क्लास में हूँ, क्लास में हूँ, क्लास में. So one homework I am going to give you. A rigid tank. It's a very, very good question. Containing 0.4 meter cube of air at 400 kilopascal and 30 degrees Celsius is connected by a valve to piston cylinder device with zero clearance as shown in figure, the mass of piston is such that a pressure of 200 kilopascal is required to raise the piston. The valve is now open slightly and air is allowed to flow into the cylinder until the pressure in the tank drops to 200 kilopascal. During this process, heat is exchanged with the surrounding. Such that the entire air remains constant at all times. Determine the heat transfer for this process. This is the question and this is the homework for you. Two 200 kilopascal. It is 200 kilopascal. ठीक है, तो ये आपका होमवर्क है, क्वेश्चन सॉल्व करना, मजेदार क्वेश्चन है। चलो मिलते हैं फिर नेक्स्ट क्लास में। which is for question practice. कोई आइडिया नहीं है, जैसे मैंने पिछला क्वेश्चन कराया था वैसा ही है कुछ, आपको सॉल्व करना है। अगर मैं ये आइडिया दे दूंगा तो फिर आप दिमाग नहीं चलाओगे ना। इफ आई गिव द आइडिया टू यू देन यू विल नॉट अप्लाई योर माइंड बिकॉज दिस इज द होमवर्क ना। चलिए, thank you very much to join the lecture. Meet in the next class. Bye. Good night. Jai Hind, Jai Bharat.